yes, oh yes. It is Longevity Industries' presentation of the Destiny of Manufacturing podcast. I want to thank our sponsors, of course, the Precision Metal Forming Association and their contributions, and also all of the support that we get from the Society of Manufacturing Engineers, that is SME. I have with me today, please put your hands together, Tom Kurfess, Dr. Tom, from, of course, Georgia Tech, where he is the HUSCO Ramirez Distinguished Chair, and also he has a joint appointment over at Oak Ridge National Labs. Tom, how are you doing today, sir?
Well, I am doing just fantastic, Dean. How are you doing today?
Excellent. It's a fantastic day. Of course, when we're recording this, it is a snow-covered day here in Nashville. Probably a little less so in Atlanta, but how are things on the streets there?
Well, things on the streets here are pretty good. But it's a Friday afternoon in Atlanta, so traffic's not too bad, and it's just a little bit cold and windy. We had rain instead of snow, so I think life is pretty good. We're still up and running here in Atlanta. That's
excellent to hear. Love to hear that. So right off the bat, tell me what new things are happening in the AI world.
Oh, well, I think, there's just so much new that's going on in the AI world and so forth. And, of course, everybody thinks, well, AI, artificial intelligence, and I'll tell you right now, Dean, really how my team looks at it is it's really augmented intelligence. So there's so much of it going on out there. And really what it's doing is, people are all afraid, oh, gosh, AI is going to replace us. Just like they say, well, automation is going to replace us. No, the jobs are going to change and so forth, but it's going to be different. It's like, no, even on your, on your phone, right? You get in there, you punch up Google Maps, and Google Maps says, oh, you going here today or you going there today? Here's the way to go and so forth. A lot of AI running all of that stuff. Both AI in terms of, here's what we think the traffic patterns are looking like, and even, to me, it's always amazing, right? It knows, hey, Monday morning, I always get together with my team for breakfast and so forth, so it knows when I'm going to breakfast. Is this where you're going today? Yep, that's where I'm going. So it's not only sort of AI for the big population, it's AI for the individual as well. And again, AI, artificial intelligence, we like to call it augmented intelligence.
Yeah, I agree with that. I think that's one of those challenges that everybody has to adapt to the new way of thinking about this. One of the funny things is I was at a conference for Voice First. So it's all vocal triggered systems and how are you going to work with those? And one of the things I found interesting, which was sort of an aha moment, was that in many cases we think that the devices are learning. It's the other way around. We're learning how to communicate with them. We learn what words we have to use in order to trigger certain reactions. And they get smarter and we get smarter. And I think it works both ways, just like if you're using a navigation system, it starts to remember your trends, things that you do regularly. And it helps to make things work smoother for you. And I think that's it's an amazing time for the new technology. Where do you see this leading us in manufacturing in the next, say, 5 years?
Yeah, well, I think that there's a whole bunch of interesting stuff going on in manufacturing with the artificial intelligence and the augmented intelligence. Certainly you're going out there and your machines you're monitoring a lot of different things and so forth. And so one of the things is, your machine is just going to learn, hey, things like, oh, I'm picking up some chatter, and I know when I pick up some chatter that I need maybe to change my depth of cut a little bit or my feeds and my speeds and so forth. And the interesting thing here, though, is that, traditionally people say, oh, I got chatter, let me back off a little bit. But there's actually some really good, fundamental chatter analytics that go on out there that I would say a lot of our high-tech, industries, the big players out there, they've got all these engineers and so forth, and they know, hey, maybe I shouldn't slow down. Maybe I should just go a little bit faster, so I can get out of that vibration, resonance and so forth. So And in fact, what AI is going to do there, I mean, this is just an example, is to say, hey, it's supposed to slow down. Let's speed things up a little bit, get rid of that chatter. So not only are we getting rid of the chatter, but we've speeded up. So now we're getting a little bit higher productivity rates out there.
Sure. And that makes sense. I think you have to find the optimum location for those things. And the only way you do that is by varying and testing different things. And I know at Oak Ridge, you've done a lot of that.
Yeah. And here's the reality actually is when you say varying and testing, look, there are, hundreds of thousands of machine tools, millions. I don't know. I don't know what the numbers are, right? But could ask our friends over at SME how many are out there, and they probably have the answer for us. But all of those are different experiments that are being run. I mean, every time, look, when I was a Ph.D. student decades ago, 30, 35 years ago, I would spend months putting, sensors on the machine and so forth and getting all this ready. And then I'd do a couple of days of experiments, making cuts or, boring or maybe drilling a hole, something like that. And then I'd spend weeks, maybe even months analyzing all the data. And I got this from my colleague, Scott Smith. He heads up the machine tool group over at Oak Ridge. Mm-hmm. We were in grad school at about the same time, and then he basically said, we did all this work today. Look, all this stuff back then, we showed, hey, these sensors are important, held it. All the sensors are sitting on the machines today. Every time you make a cut in your shop, you're running that experiment that we did as PhD students 30, 40 years ago. So all of a sudden, there's a whole bunch of information out there. And this is where, again, AI can take all of this information and figure out, where to go and what we should be doing with the machine. So, this having some really cool technology, I would say, is on the higher end. And but there are also some cool things, if you're interested, where I would say just some pretty simple things that AI is helping us out with.
Right. I agree with that. And I think the other thing that people sometimes overlook is how much that impacts affordability. When you start to share that data and people learn from each other, that kind of open source communal experience gives you a lot more advantages. You just look at some of the programming stuff that's out there now, and if you look at, we'll look at drone technology. You can buy a drone for under a couple $100, and it's using technology that was made through millions and millions of dollars of research. And
sure.
And that's what changes some of those things. And that same thing in when we look at how we're doing vehicles now that are working their way towards self-driving, at some point keep working towards that. What everybody has is that utopian vision where they're all going to drive themselves. Maybe a little further off than some people would like to believe, but I think there's so much infrastructure that has to go into that, and that's going to come from sharing this type of augmented information as we keep moving forward.
Oh, yeah. I mean, a couple of thoughts there, and that is, again, people are like, I don't want to share all information and so forth. I think a lot of us are running Google Maps or Apple Maps and so forth. And, you get real-time traffic information. It says, hey, there's a jam here. Here's another way to go. But that traffic information is coming from the fact that when I load Google Maps up, I agree to a whole bunch of things. I think people don't pay attention, right? They're just kind of hitting the okay. And they are tracking the phone, and that's how they figure out if there's a jam. Hey, the phone is on this interstate, and it's not moving. So there's traffic there. But alternatively, if I know a couple of good shortcuts during a traffic time, what's going to happen is it's going to see, hey, this phone is moving here and da-da-da-da. And it got from, point A, maybe the airport, to this guy's home in a whole lot less time than going through traffic. So not only is it helping you where you're going, but it's also learning all of your little tricks and shortcuts and so forth, and then really sharing it with everybody, right? So it's great. And we see that, we see that really happening. And again, as you said, AI, I think about it as augmented intelligence. We've really done a great job in terms of augmenting the driver. And then you mentioned the driver, self-driving cars. We're probably a little bit away from I think the technology is pretty good and so forth, but I think it's going to be a few more years before we really have these self-driving cars and off we go. And a lot of that is just we've got to get the laws together for it. Mm-hmm. But the reality is much of the technology is there, and it's really useful for us. I think, if you have a relatively new car, if you're approaching, if a car in front of you is braking and you're not braking, it's going to give you a heads up and maybe even engage the brakes. So it's augmenting that driver and it's just making sure that hey, we're much safer out there.
Yeah, and I think that's a great point, because we have to look at the fact that how much better we are today from things. You think about how airbags work and how much different technologies we've incorporated into vehicles to help us drive safer. I think we've forgotten days from years and years ago when we didn't have things like anti-lock braking systems and you just spun out, and potentially it was even worse. And a lot more accidents were caused because of that, because of the braking side of it, of somebody just slamming on their brakes and turning their wheel was far more dangerous than actually controlling that braking. And I think that aspect of it, we have to think about. If we keep moving forward and increasing our awareness of this information, we can all improve because of it. What are some of the technologies you see being incorporated, like vision systems and more types of sensors?
Well, so I have to say, I am very bullish on what I would say is sort of the integrated vision systems, vision sensing systems, and so forth. And in particular, what I would call augmented reality. So I think people see virtual reality. There's virtual reality, augmented reality. There's extended reality, actually, AR, VR, XR. So sort of the augmented reality is I've got my glasses on and then I have a picture painted over, so I'm still looking at the real world, but I have some stuff that's, being put up on my glasses. And I think if we walk around, I think it might be Google Maps. They have something similar to this where you can be, if you're walking, right? I don't think it works for driving, but if you're walking through a city, you can bring this thing up and it'll locate where you're at and so forth and actually show you where the path is right on top of the picture that's in front of you, right? So it's not it's a real-time picture coming through your camera and you see where it's going. And I think it's going to be the same thing. I'm very excited about it in production operations. Look, we're in a plant. You got to wear your safety glasses. So what if they were augmented reality? Now look, you need to, let's say I got to change a tool. So I got to change an insert. So I go into my machine. First thing is when you're going to that machine to make sure everything's locked out in the whole bit, so that that those sensors know, okay, you're in there, it's locked out, it's not going to move. And then I pick up a tool. Your glasses that'll have little cameras on them. They're seeing, yep, you've got the right tool. You pick the right tool up. You're putting it in the right orientation. You're putting it in the right tool holder. You even you sort of tighten things down. And so really what we're doing is we're augmenting the human. To make sure, and we're augmenting humans at all different sets, skill levels, right? So this is not just the person who's the super duper high end 5-axis programmer. It's also the person that's even, loading and unloading machines. Did you get the machine in there? Hey, did you blow the chips out of the truck to make sure it's clean and so forth before you put the part in there? So just everything, and again, not taking over from the person. And I really want to stress this: you're augmenting the person. People are amazing. Right? I mean, just try and get a robot to do all these different things. You can do it. It's a lot of programming and so forth. But if I'm making 5 or 6 different parts in there and so forth, you're so much better off with a person. But you augment them with this capability, with your augmented reality dogs. And all of a sudden, you really make sure that they're as productive as they can be. And you in fact, and you even lessen their load. You don't have to worry about all these different things. We'll make sure, in case you miss something, we'll make sure that you're good to go.
Mm-hmm. That's an interesting perspective, because one of the areas that I see, even on the more simplistic, think about job-wise, that doesn't require a lot of technology, but stacking and going through like a logistics company where they're using augmented reality to, okay, here's where this part is. You keep moving down this path, you turn here, and on the third shelf, this is where you find this part, and it overlays where it is. And
I mean, actually, a really kind of cool example. I won't name names and so forth, but I was at a big warehouse for a supply company, and here's something that sort of struck me as interesting. Okay, I got to go get a 1/4 inch 20 screw. And okay, the person knows where they have to go in this big warehouse to go get the 1/4" 20 screw or the pack of those screws. But it's not like the hardware store, right? You go to the hardware store, hey, where do I get the 1/4" 20 screw? And like the screws are over there in this aisle and so forth. And you go there and then you look, okay, here's the one I want. What happens in these big warehouses is that 1/4" 20 screws in one location, but if you're looking for, let's say, a 1/4" 28, it's in a very different location. It's maybe even down a different aisle, because the idea is you don't want to have these things. It's in the hardware store, they're all together, so somebody can look and try stuff out and hold it. But in the warehouse, you have the different locations, so you don't pick the wrong one up, right? And again, you can imagine if I have my virtual reality goggles on, if I'm reaching for the wrong thing, it says, hey, it's the wrong thing. It's the next one over. This box is red. This box is green. That's the one you want to get. And by the way, when I pull this box out, it goes automatically to inventory saying, okay, we just took this box of screws out. We need to order, a replacement box.
Yeah, that is really, I think, something we've learned from, again, we've taken some of this augmented intelligence from experience, where we've gone through this and, hey, well, what's causing the problem where they're getting the wrong screws? Well, they're right next to each other. It's very easy to pick up the wrong one. They look the same. It's very difficult to distinguish one from another. Okay, well, how do we prevent that? And I think kind of the necessity is the mother of invention sort of thing, where, okay, well, what's causing this problem? If we get down to the root cause, we can find solutions around those. Have you seen some of like the technologies that are being incorporated where people are remotely operating some of this equipment? For instance, like fork trucks, they're driving fork trucks remotely, or they're doing assemblies remotely with the use of robots. Do you see a lot of opportunities there for that to be developed?
So, I think the answer is, I want to say the remote operation is kind of okay, but again, it's one of these things where, if you can withstand a little bit of a delay, that might work things out. It's actually even like how the Mars rovers work, right? I mean, well, in fact, they're so far away that you have to have some intelligence here. You say, hey, go from point A to point B. They can't actually drive it because of the delay,
right?
But they say, hey, I want to go here. And then you let the system itself figure out how I'm going to get from point A to point B. And I think that's the same thing over here. And then you bring up actually an excellent point, Dean, and that is, what you can do is you could let the machine deal with the details, right?
Mm-hmm.
And you let the person, the individual, the human, deal with sort of the bigger picture of things. And again, to me, it gets back to It gets back to even when you're driving. I mean, the thing to me that Google Maps does when I have this real time map is look. I always could get from the airport to close to where I needed to be. Right, you get on the interstate and you get to interstates and the whole bit. For me, it was always the last maybe mile when you had to get on a bunch of little streets and so forth, and which way do you go, et cetera, to get to your hotel, for example, in the evening. And so it's the same thing there, right? I mean, with Google Maps, get on the interstate, drive for 20 miles. Okay, well, I could drive for 20 miles. And then you get off and left turn here, right turn here, left turn here, and, there you're there, bing, And by the way, if you missed it, it says, hey, you missed it. You need to go back around, and it sort of helps you out. Same thing, I think, in the, in the shop. So there's going to be some remote stuff, if you will, but I think it's going to be a little bit more at a higher level.
Mm-hmm. I think the other thing, when you said that, it triggered something for me, which was remembering driving in Chicago. And anybody who's driven in Chicago, GPS is great if you have a sort of line of sight from satellite systems. But when you go on lower whacker or lower whacker, you make one wrong turn. Next thing you know, it's okay, you're off track. And then it's rerouting you again. And it's like, what did I do wrong? Because it's once you start to lose that control from the system, if you don't actually have physical systems there to replace those, so maybe there's an RFID sensor or things like that on these other positions, like you say, when you get close to those types of places, so that you don't, it needs to have a finer detail system. You can have that generality, kind of like what you're talking about with the Mars rover. You can have this broad, okay, get from point A to point B, but then where do you take it when it has to get to that last portion where it has to be much more controlled? And right. How do you increase that, I don't know what you want to call it, I guess, the actual finite element there when you get to the last part?
Yeah, well, when you need that resolution, and then again, you have different situations. So I was chuckling because I was like, well, I grew up in Chicago, and, to me, Chicago is pretty straightforward. You got, it's laid out in a really nice grid, and, if the street you're on is one way, well, you go one block over, and the other street is going, in general, it's going the other way.
Right.
And, where I really need the help, and again, to me, that's like, okay, I'm programming a 3-axis machine. That does make a lot of sense, and I can think about X, Y, Z, and so forth. But now, I think, okay, now let's go to program the 5-axis machine. That's a whole lot harder. That's almost like driving in Boston, right? I mean, good golly, the roads aren't straight over there, and I might go one way in one direction, and then I go to the next street, and it's still the same direction, and the next street is, or maybe even worse, if you've been to Pittsburgh, right? Yeah. One wrong turn in Pittsburgh, and you're going across a bridge or through a tunnel, and all of a sudden you got a mountain between where where you wanted to be, or a river, and so forth. So, and again, so it's one of these things where, yeah, this type of stuff can be really helpful, and the more complicated, the problem, or the other thing is sort of the bigger consequences of wrong decisions, the more valuable this AI or this augmentation is going to be to people in the shops. Right.
I think that you hit it on the head. Is what is the consequences of a wrong decision?
Yeah.
And yes, I have driven in Pittsburgh, and you are absolutely right. You make the wrong move, and you're like, I'm going to get there 10 minutes early. Uh-oh, made a mistake. Yeah. I'm now a half hour late because now I'm somewhere else, and I'm in traffic again.
Yeah, and I remember. I mean, look, I grew up in a machine shop, and I remember being in the shop, and you're loading parts into a machine, and certainly there are, I'm sure you all loaded parts in the machine, and if you're not paying attention, maybe you load the part in backwards. And let's say you think about, if you think about like a coffee cup, like a Yeti or something like that, and I'm going to spin a boring bar there and bore it out. Well, look, I got a cylinder, and I'm putting it into a 3-jaw chuck. If I'm not paying attention, and it happens, right? I might put the cup in instead of, in one way, I could put it in upside down, and so all of a sudden my boring bar slams right into the bottom of the the cup, and it happens, right? Mm-hmm. And so if you just turn around, and it just, it always happens at Friday, right before closing time and the whole bit, right? You're just kind of, you're thinking somewhere else and so forth. So again, it's your safety glasses will just flash red. Maybe you won't even let you start the machine. You're like, well, what the heck, and it's telling you, hey, you got the part in wrong. You're going to crash the machine. Oh, okay. Then you flip it around. And again, consequences of crash the machine, versus, oops, I got it in backwards, let's flip it around. I mean, it's like driving down the road, right? I think we've all probably been a little bit distracted or not paying attention. All of a sudden you go through a stop sign. And in general, in general, you're like, oops, and you don't get into an accident. Sometimes, you could get into an accident. But look, if you're driving down the road and you're either your glasses, your sunglasses, or you actually had a heads-up display on the windshield, which we're starting to see is going to come out, if that octagon is coming down, which is the universal stop sign, if that octagon is coming down the road and your car says, he's not braking, just flash up the octagon. Hey, look it over here, and then you see it, and then you'll hit the brakes. I mean, that's, it's really a useful thing.
Yes. I think that line is going to get more blurred between what type of technology you're looking at, as far as artificial intelligence, or as you said, augmented intelligence, is going to get more integrated into your VR, your AR, your sensing, your IoT, and that line is going to get more and more blurred as we continue moving forward. How do we try to make sure that the technologies can work together. Because I think one of the problems that we often see is that systems don't like to play well together as much as we would like them to. How do we get to more of that solution where we, even if necessarily they're not communicating, but we can share the information in one way or another?
Well, and I think, a couple of things have to happen. So in terms of sharing information, people are very sensitive, and you can, almost every day you can pick up the paper about people being concerned about sharing information and so forth. And, on the other hand, most of us are running Google Maps or Apple Maps and so forth. So even though people are sensitive about sharing information, most of us, by using these apps, these companies are tracking us and so forth. And so I think that you really just have to provide, and by the way, even if people knew that, they said, oh yes, I understand that Google is tracking me. I understand Google is tracking me, and yet I still continue to use Google Maps. Frankly speaking, I am happy to give my mobility data if they can keep me from getting lost or keep me from getting, wrong traffic and the whole bit. And so I think part of it is going to be, yes, we have to share the data. We have to make sure that when these data are shared, that there are some security. Why? Again, I'm driving around, Google is tracking me. But look, I might not want to have that information shared, sort of linked to me personally. I'm happy to provide information to everybody else saying, yeah, my phone is going down Interstate 85 and it's doing 60 miles an hour, so there's no traffic. I'm not happy saying, whoa, hey, Tom Kurfess is driving down Interstate 85 at this time, going 60, or maybe he's over the speed limit and so forth.
Right.
So just to make sure that we have privacy there and so forth, and that people understand it. But there is a value proposition there. And then I think the other one that you really hit on the head, Dean, is just the communication. I think a lot of companies in the past have said, well, hey, we're going to keep communication closed, so you've got to buy our sensors and run our software and so forth. But I think culturally people are now getting used to, hey, I've got a phone. I want to do a Fitbit, or I want to do a Bluetooth headset or speaker. They connect with something called Bluetooth, which is a pretty standard mode of communication now, or maybe they're using Wi-Fi. So I think that some of these standards are going to come along, and people are just going to demand it, and the OEMs for, let's say, machine tools or robots and so forth are going to start to open some of these things up because they're going to be pressured by the market. So I think you're going to see more, and in fact, I even see it today. A lot of the companies that I work with, they order a machine tool and they say, oh, it must have MT Connect on it, so I can communicate with them, I can do what I need to do. Or maybe it's OPC-UA or any of the other protocols on there. And so I think it's coming, and I think it's going to be customer driven because they just see the value to it.
Yeah, I think you're right about the way that systems have to have some level of integration, and the market is going to drive that. I've said this before, that one of the things like SAP, I don't see the tail wagging the dog there. The SAP is going to dictate an awful lot because they have so many users. It is very difficult for somebody else to say, well, we think it should go this way. A company like SAP compared to, like Link Systems, who I work for, they, is our customer base going to be enough to sway the market like an SAP does? The answer is no. Just flat out isn't, unless it was so much better, and in any case, companies like these large companies, which are billion and billion dollar companies that deal in information and deal in communication, artificial intelligence and things like that, and integrate those into their other products, have so much sway in the marketplace. It makes it difficult to see that wouldn't kind of navigate to some areas. And we've seen it across the board that the way that things are going is people do want integration. Like you said, I want to be able to, I want to be able to use, let's say, Google Maps or Waze or some navigation system, but then I want to be able to navigate using voice. So it has to have some voice integration, and it has to have a GPS integration. And then maybe you want to be able to say, I'm going to Nashville to a certain restaurant, or going to Atlanta to the High Art Museum there.
Right.
So I also have to have ability to either go into a directory or your address book, or go into search the web. So there's already some levels of integration that have to pull information from other places in order to make them more user-friendly, because we want that. We as users want to have this. I want to be able to say, show me the nearest restaurant, or show me the nearest Italian restaurant. Okay. And be able to navigate to those in one app, rather than going somewhere, getting the address, copying the address, pasting it there, without having to do that all with my hands. I want to be able to do it hands-free. So how do I do that while I'm driving? And the kids are in the back and they're yelling at me to get to the restaurant, not to keep stopping and trying to navigate. So
Right. Oh, I think the same thing. It's like you've got your Fitbit. Look, I've got a Fitbit or whatever I'm going to monitor my health with. It doesn't matter that I have an Android phone or an Apple phone or a Windows phone.
Right.
I get it into pairing mode. I pair it up. I download the software, the app for it, and it can monitor me. Why shouldn't I, on my machine tools, basically have a sensor package that goes on my machine that tells me what the health of my machine is, or that my process is, and people are going to say, hey, we're going to do this, and here's what's going to happen is, one OEM machine tool producer is going to say, sure, we'll provide that interface for you, then now you're going to say, okay, well that's the one I want. I mean, why would I buy a machine tool that doesn't allow me to do all this stuff? I mean, if you take a look at I think they just the other day, right, the demise of BlackBerry. I know there are whole different reasons. I think they just shut the last set of servers down, right? But I think it's just the market just moved too fast. So you either playing it or you're just going to get passed on by. So
right. And when it comes to technology, do you see that certain aspects are going to be? I think that people get in trouble when we start looking at technology from a standpoint of machines. Let's say, for example, if you take a look at a machining center, am I looking at the efficiency of the machine, or am I looking at the efficiency of the person operating the machine? And
yeah.
Because
I think that, go ahead, Dean.
I was going to say, because the problem is that when you look at asset utilization, and when you look at most systems, people look at the time cards. Time cards dictate a lot of times the operator's efficiency, or if this person isn't here, what happens? Whereas you look at OEM efficiencies, it's usually machinery. It's all geared towards, is that machine running or not? You know what I mean? For as far as the differentiation between the two, even though they're both tied together, that person has to operate this machine. Just because the machine is operating does not mean that is necessarily the best utilization of the person.
Right. No, and I think that's exactly right. It raises two interesting points. And the first thing is really what you want to measure is, it's exactly right. It's how is the team performing? So the machine and the person, how are they performing, and how do we make sure that we really get the most value out of both the individual and the machine? There was a really nice study. I think this was an MT Connect. They used MT Connect on this, but it was a company where basically you have you're running your standard 2 or 3 shifts, and what they did is they monitored when shift A is finished, the new person comes in and she starts running the machine. But one of the things that they noticed is that there was a slowdown in production at shift change. And I mean, of course, because what happens is you go in there and then you want to look at all the readings, and you want to make sure you got the right tools, and hey, which one's wearing out, and so forth. The machine is running fine, and it just takes a little bit of time to settle in. Mm-hmm. And so what they did is they started to just slightly play with the shift numbers. So the A person, I'm sorry, the B shift person, she would come in a few minutes early, and the A person, he would head out a few minutes late. So now they had some overlap. And I don't remember exactly what the time was, but it was something like 10 or 15 minutes, something on that order. And if they have that much overlap, basically they increase the productivity of the machine by, I think the number was 17%, which is just crazy if you know about productivity numbers in a machine shop. So it was well worth the extra, whatever it is, 30 minutes of time to have these two people together for about 30 minutes, just talking about, hey, here's what's going on, seeing what's going on, and so forth, and making sure everything has got a smooth transition. That being said, I do think that we have to be careful, because when you say, hey, we're going to measure the productivity of a person, we do have to be careful about some of the privacy issues. And those, there are privacy laws certainly in the U.S. There are other privacy laws that will be, for example, in the EU and so forth. EU typically being a little bit more stringent than the U.S. So one of the things that you've got to be very cognizant of is, okay, well, hey, if we're monitoring a person, we just need to make sure that we understand that it's monitored, that we're not trying to track the person or get, into any of the privacy issues. So, all sorts of interesting things that go on there. So that's, it's again, the more we monitor, the more we risk some of the privacy issues. So, you just have to be careful about some of those things.
Yeah, that's a great point. And that is definitely something we have to be cognizant of. And we have to make sure that we come up with ways to protect that privacy as part of that.
Yeah, a really cool example. There was a group over in Germany. I forget exactly who was working on this, but you're familiar with light gauges, right? So you've got equipment that operating, let's say, robots, and there's a light gauge around. So if you get too close to the robot, you break the light beam, and it shuts the robot down. It's a safety, the safety thing, of course. And they had developed what I'll call is a virtual light gauge. So instead of having actual beams that you're breaking, you've got camera systems that are, tracking people going through the plant. And if the camera sees you get too close to the robot, it's like breaking the light beam. Yes. But of course, the difficulty, and again, if people are worried about privacy, the first thing you hear is, I've got cameras tracking people. Right? And so one of the things, in order to implement that, they had to make sure that there was a guarantee that, within 2 or 3 or 4 minutes, whatever it might be, that those images were deleted. So we couldn't track a person moving around in the factory and so forth.
Right.
So, so there are always solutions to it, but you just have to pay attention to these things. Sometimes all of the data and sharing all the data and so forth, can start some critical issues.
Mm-hmm. Tom, we are just about out of time, sir. I want to thank you for being here. Well, we can always do another show.
I love it, man. I love talking about this stuff and so forth. And, as I always tell my students when they're taking exams, time flies when you're having fun, man.
Yep, I agree. Thank you so much, Tom, for being here. We really do appreciate it. And everybody go out and make it a great day.
All right, Steve, my pleasure. Have a good one.
Yeah.